This channel does not promote or encourage any illegal activities. All contents provided by this channel is meant for educational purpose only.
Hello friends, இப்போ தான் நம்ம சேனல் ஃபர்ஸ்ட் டைம் வரீங்கன்னா சப்ஸ்கிரைப் பட்டனை கிளிக் பண்ணிக்கின்னு அது பக்கத்தில் இருக்கிற பெல் பட்டனை கிளிக் பண்ணிங்கன்னா ஆல்ன்ற பட்டனை ஆன் பண்ணி வச்சுக்கோங்க. அப்படின்னா தான் நான் போடுற வீடியோ உங்களுக்கு நோட்டிஃபிகேஷன் வந்து.
Magnets have a north and a south pole. Around these poles are fields of magnetism that extend out in all directions. These invisible lines of magnetic force are called magnetic flux. These lines of flux leave the north pole of a magnet, loop around, and enter on the south pole. Where the lines of flux are more dense, for example, near the poles of the magnet, the magnetic field is strongest. As you move away from the poles, the lines of flux are less abundant, so the magnetic forces are diminished. Two magnets will repel each other if like poles are facing each other. As you move like ends of two magnets near each other, they will be repelled. Notice how the lines of flux bend as they impinge on the flux lines of the opposing magnet. This magnetic behavior will occur for both like ends of a magnet. If unlike poles of a magnet are facing each other, the forces will attract each other. As you move the magnets closer to each other, the lines of flux join and condense, increasing the forces of attraction. When unlike poles of a magnet are lined up end to end, their combined forces create a unified magnetic field and thus behave as a single magnet. When electrons move through a wire, a magnetic field is created at right angles to the current flow. If the conductor in which the current flows is a straight wire, the field takes the form of concentric circles or rings of magnetic force around the wire. A convenient method to determine the direction of magnetic current flow is to use the left-hand rule. The left-hand rule states that by pointing your thumb in the direction of the current, your fingers will naturally curl in the direction of the flux of the magnetic field. Reversing the direction of current, you can use the left-hand rule again to show the direction of the concentric circular force around the wire. This method can be used to determine the direction of the magnetic flux, as long as you know the direction of the current. One important aspect of electromagnetic study is the process of magnetizing magnetic materials. Magnetic materials, for instance iron, are made up of microscopic domains. When the material is unmagnetized, these domains are arranged within the compound in no particular order. When the material is brought under the influence of an external magnetic field, these domains orient themselves in alignment with the magnetic poles. This can be done by wrapping the unmagnetized material in wire and adding an electrical current. North will be created at the end of the material in which the current is directed. When the external field is removed, these domains remain in alignment, producing a magnet.